Hello class, and welcome to section 02, which is about the properties of numbers. By the end of today's lesson, you will be able to recognize and use properties of equality, addition, multiplication, and algebraic properties. So we're going to start with the properties of equality. These are things that you've definitely seen before. You already know these things, but now we're just going to put names on them so that we can identify and use them. For our purposes within algebra, most of our ability is just going to be actually using these properties. When you get to geometry and you're writing proofs, it's going to be important that you know the names of the properties. So I just want to introduce those to you right now. The first one we have here is the reflexive property, and this is going to say that the number is equal to itself. So, for example, we could say that 5 is equal to 5. Or you could have it written out as an expression, saying that 2 plus 3 is equal to 2 plus 3. Notice when we're doing this, the numbers stay in the exact same order, and it's the exact same numbers that are equal to each other. Our next property here is going to be the symmetric property, and that is going to say that if a number plus another number equals a third number, then that third number is equal to the first two being added again, or subtracted, or multiplied, or divided. So this is basically saying that if you have something that is equal to a number, then you can flip which side of the equal sign things are on. Notice, again, the order of that adding didn't change. It could have been 4 minus 6, it could have been 4 plus 6, divided, multiplied, anything, as long as the answer is equal to it. And this just says you can flip-flop what is on the left and the right side of the equal sign. Our third property here, the transitive property, is going to say that if A plus B is going to say if A equals B and B is equal to C, then A is also equal to C. So what this is saying is, for example, if 7 plus 8 is equal to 15, and 15 is also equal to 5 plus 10, then we can cut out that middle value, that 15, and say that 7 plus 8 is the same as 5 plus 10. So this allows you to plug in different facts that are equal to each other. Kind of think of the transitive property as a fact family. All the different things that you can plug in that are going to equal the same thing. And then the last one, this substitution property, is going to be if A is equal to B, then B can be plugged in for A. So what this means is if A is equal to 8, then if I have 3 plus A, I can say I have 3 plus 8. So you can plug in that value. This also works for if you are saying something like 4 plus 2 times A. You can also say that that's equal to 6 times A. So this property allows us to either plug things in or solve and replace values to simplify things down. Next, we're going to look at some properties specific to addition. The first one is the identity property, and that's going to say that if you have a number plus 0, it's going to equal that number. So for example, if you have 9 plus 0, it still equals 9. The inverse property says that if you have a number and you add the opposite of that number, you're going to get 0. So for example, if you have 9 and you add on negative 9, you're going to get 0. You also might just see it written out as 9 minus 9 equals 0. So this is basically telling you that adding and subtracting are inverse operations, and that adding 0 isn't going to change anything about the number. We have these two similar properties with multiplication. For the identity property, instead of being adding 0, the identity of multiplication says that if you take a number and multiply by 1, you still have that number. So again, if I have 9 times 1, the answer is still going to be 9. Nothing is going to change. The inverse property, again, is going to say that we have opposites. In this case, it's going to say a number multiplied by the fraction of that number is equal to 1. So if I have 9 times 1/9, that's going to get us to 1. So that's saying multiplication and division, because fractions mean division, are inverses. And then the 0 property is saying that if you multiply a number by 0, your answer is going to be 0. So if I have 9 times 0, my answer is going to be 0. So these are properties that are specific to multiplication. The last two properties we're looking at, the algebraic properties, are going to apply to addition and to multiplication. So the commutative property is going to say that if you have a number plus another number, you can switch the order that you add them in. So for example, if I have 4 plus 5, that's the same thing as saying 5 plus 4. Both of those are going to equal 9. The same applies if you are looking at multiplication. I can say A times B is equal to B times A. So I can say 4 times 5 is the same thing as 5 times 4. Both of them equaling 20. The associative property is going to talk about allowing us to regroup things with parentheses. So the associative property says that if I'm adding three numbers, so A plus B in parentheses plus C, that's going to be the same thing as A plus, and then change the parentheses to B and C. So for example, if I have 3 plus 4, which is 7, and I add on 5, that's going to be the same as if I have 3 plus 4 plus 5. Following PEMDAS on that right side, I would do 4 plus 5, which is 9, then plus 3, which again is going to give me 12. The same thing applies if you are looking at multiplication. So A times B in parentheses times C is equal to the same thing as A times BC. So if I have 3 times 4 in parentheses, that gives me 12, times 5 gives me 60. On the other side, if I have 3 times 4 times 5 in parentheses, that 4 times 5 in parentheses is going to equal 20, times 3 is again going to give you 60. I want to point out on these algebraic properties, they do not work for subtraction or division. So if I tried to subtract, if I did 4 minus 5, that's going to give me -1. That's not the same thing as 5 minus 4. So the commutative property doesn't work for subtraction, neither does the associative property. Because if I took and said 3 minus 4, which is -1, minus 5 is -6, that is not the same thing as saying 3 minus, and then if I have 4 minus 5, that's -1. -1 minus 3 gives me a +4. So again, those are not equal. The same thing happens if I look at division. If I say that I have 4 divided by 5, that gives me an answer of 0.8. That's not the same thing as 5 divided by 4, which is 1.25. Same thing happens with division and the associative property. If I said I have 3 divided by 4, which is 0.75, and then divide by 5, that's going to give me 0.15. On the other side, if I have 3 divided by 4 divided by 5 in parentheses, 4 divided by 5 is 0.8. 3 divided by 0.8 is going to give me 3.75. So that does not work. So the algebraic properties only apply to adding and multiplication, not to subtraction or division. Just a quick summary here. So this is just a quick summary chart that you can look at. When you are using these properties, you are mainly going to be using as you are solving these bottom 6 properties. These properties of equality are more so just when you are moving things around an equal sign. You're not really going to use them as an explanation for evaluating. When you are using these properties to explain a process, you want to be as specific as possible. So yes, every time you do something in a problem, you could call it substitution, but if it's one of these specific properties up here, you want to give it its specific name. So let's go through an example. We're going to evaluate and name the properties used. The problem is 7 parentheses 4 minus 3 parentheses plus 5 times 1/5. So the first thing I'm going to do when I'm following PEMDAS is I'm going to do what's inside of the parentheses. So 4 minus 3. That's going to give me 7 times 1 plus 5 times 1/5. Now if you're looking at your property list here, 4 minus 3 is not any of these specific properties. So this one would be substitution. So you would say off to the side that's what you did to solve was substitution. Then we look, and the next step in PEMDAS would be to multiply 7 times 1. When you do 7 times 1, that answer is 7. So then we have 7 plus 5 times 1/5. When you look at the list of properties, yes, 7 times 1, you plugged something in, but it's a more specific property, which is that identity property. We multiplied by 1. So this step we would label with identity. So we want to give it the most specific name that we can. Then following PEMDAS, our next step would be to do 5 times 1/5, and that's going to give us 1. So I've got 7 plus 1, and that's going to be that inverse property that we used there. And then for the last step, I have 7 plus 1, that's 8. Adding 1 is not a specific property, so I'm going to call that substitution. So your goal here as you are evaluating is to be able to identify each step of the process. This one is already solved for you. Go ahead and name the 2 properties that are missing. To get from part 2 down to part 3, we did 8 minus 8. Those are inverses, the additive inverses. And then we did, for the next part, 1 times 3, which gave us 3. That's the identity of multiplication. Last thing you might encounter is being able to use the properties to make things equal. So this is going to potentially go into those properties of equality or addition or multiplication, etc. So here I'm looking at 2 plus 8 equals 8 plus something. In order to make that equal, that x is going to be 2. And then you're looking for the property that says you can reverse the order of addition, and that's going to be your commutative property. And then for this second example down here, I have if 3 plus 8 is 11 and 4 plus something is 11, then 3 plus 8 equals 4 plus that something. Right here, we're trying to think about 4 plus what is equal to 11, and we all know that 4 plus 7 is equal to 11. And then if I have a first thing and a second thing, both equal to a third value, and I replace that, that becomes the transitive property, saying that those 3 things are now equal. Go ahead and try these 2 on your own. For the first one, that's our reflexive property, same numbers staying in the same order, so they're exactly equal. And then the bottom one, we are changing the location of the parentheses, and that is going to be the associative property. If you have questions about this or anything else from the lesson, please let me know when you get to class.